All right, welcome to The Explainer. Today we're diving deep into a world that's literally under our feet, the world of infrastructure. We're going to witness a classic showdown between two absolutely critical materials. And trust me, this isn't just about pipes. This is about the arteries that keep our modern world alive.
I mean, really think about it for a second. That clean water coming out of your tap, the wastewater being carried away, even the lines that protect our power and internet, what's doing all that heavy lifting? The answer is this huge, unseen network of pipes. And, the choice of which pipe to use? It has massive consequences for the cost, the safety, and the sustainability of our cities.
So let's meet our competitors. In this corner, weighing in as the established heavyweight champion, we have Ductile Iron, trusted for its raw strength for decades. And in the other corner, we've got the challenger, GRP, or glass-reinforced plastic. It's the modern, lightweight contender, really engineered for a whole new set of problems.
Okay, let's get right to it and ring the bell for round one. This is all about raw power and resilience. We're talking fundamental strength and, maybe even more important, the ability to actually last for the long haul. Now, if you just glance at the numbers, you might think, okay, ductile iron wins, it's got higher tensile strength. But wait, that's not the whole story. The real secret is in those other numbers, the ones that tell you how much a material can flex and bend, and that's where GRP's ability to bend without breaking becomes its secret weapon. And this is where you see that flexibility isn't weakness at all, it's resilience. So if you're in an area with unstable ground or, seismic activity, GRP can actually bend and adapt. The more rigid ductile iron, it might just crack under that kind of strain. And that right there is a total game changer for how we build things in a world that's constantly moving.
But look, the fight for survival underground isn't just about movement. It's this constant, brutal battle against corrosion. And here, wow, the difference is night and day. GRP is just naturally immune. It doesn't rust, it doesn't degrade. Ductile iron, on the other hand, is basically in a fight for its life from day one, needing all these expensive coatings and protection systems just to fend off decay.
And you can see the result of that battle right here on this chart. In those really tough, corrosive environments, GRP's lifespan can be more than double that of a protected ductile iron pipe. I mean, think about what that means in terms of replacement costs and service interruptions for a city. It's huge.
All right, let's move on to round two, where we're going to look at real-world efficiency. We're talking about everything from the moment the pipe shows up on site to the energy it takes to push water through it for the next half-century.
First off, just look at this weight difference. It is absolutely staggering. For the exact same size pipe, GRP is about a quarter of the weight of ductile iron. And that's not just some small detail. It literally changes everything about how you get the job done.
See, this isn't just about being easier to lift. This creates an incredible chain reaction. Lighter material means you don't need as much heavy equipment. Simpler joints mean faster handling for the crew. And the bottom line? You can get projects done up to 60% faster. That saves a ton of money on labor and means way less disruption in our busy cities.
Now, efficiency isn't just about installation. It's also about what happens inside the pipe for decades to come. And that's measured by something called the Hazen-Williams C-value. Just think of it like a rating for how smooth the inside of the pipe is. A higher number is better. It means less friction, kind of like a faster, more awesome water slide.
So, because GRP has this factory-smooth resin surface, it gets a really high C-value, around 150. Ductile iron, with that cement lining it needs, is just a rougher ride for the water, coming in closer to 130. That means water flows through GRP with way less resistance.
And this difference in smoothness, it's not just some academic detail, it translates directly into real-world energy savings. Pumping water against less friction takes less energy. We're talking potentially up to 20% less over the entire life of the pipe. That is a massive operational saving.
All right, it's time for our final round, and you know what that means. We're going to follow the money. We're going way beyond the initial sticker price to see how all these things, installation, maintenance, energy, lifespan, add up to show us the true cost over the long term.
And this is where the whole story really comes together. You can see it right here. GRP often starts with a lower material cost, but then the savings just start to compound from there. Lower installation costs, practically zero maintenance thanks to that corrosion resistance, and as we just saw, lower energy costs for pumping.
And this, right here, could be the knockout punch. When you add all those savings together, especially in those corrosive environments or high-flow systems where efficiency is everything,
GRP can save up to 70% in total costs over its entire lifespan. 70%.
So, after 3 rounds covering strength, efficiency, and cost, how do we declare a winner? Well, the real answer is, it's not that simple. It really depends on the job. The best choice isn't always the same. It's about picking the right tool for the specific challenge you're facing.
This chart really breaks it down for us. Ductile iron is still your champion for situations where you need extreme impact resistance or you're handling crazy high pressures. But for all these modern challenges, like desalination plants dealing with corrosive seawater or cities in earthquake zones, GRP's unique mix of flexibility, lightweight, and corrosion-proof nature makes it the clear winner.
So what's the big takeaway here? It's that the world of infrastructure is getting smarter. Choosing a pipe isn't a simple one-size-fits-all decision anymore. It's about this sophisticated process of matching modern materials to modern challenges so we can build smarter, more resilient, and more cost-effective systems.
You know, this choice, this exact showdown between old-school tech and modern innovation, is happening right under our feet every single day. It's shaping the cost, the safety, and the environmental footprint of the world that we are all building together. The real question is, are we making the smartest choice?